Foundations of Amateur Radio. Today I'm going to talk about SWR, or Standing Wave Ratio. As amateurs we use this term all the time. We expect to see it on a meter or display near our transmitter. We buy specific gadgets to measure it, and often we seek to find the lowest possible SWR. As I've said in the past, the perfect antenna cannot exist. In the same way, a perfect connection, the feed line, between an antenna and transmitter can also not exist. The perfect match is a 50 ohm match, but a dummy load is the perfect match and its purpose is specifically not to radiate. So what's all this about then? Let's start in a swimming pool for a moment. Imagine that this pool is really long and skinny, say 100 meters long and a centimeter wide. Stand on one side and make a splash. The ripple of the water radiates from the source of the splash, you, to the other end of the pool. The end wall bounces the ripple back to you and bounces back and forth until all the ripples have dissipated. Now, if you kept splashing about and waves were rippling back and forth while you were splashing, some of the ripples would happen at the same time as a splash, and some of the ripples would happen at the time between two splashes. That means that sometimes the splash and the reflections would sit on top of each other, making a higher wave, and at some times splashes and reflections would be sitting below each other, making the troughs between splashes deeper. If you replace the water with electricity and the pool with a transmission line, the same is true. If you made an electronic splash, say a transmission from your radio, into the feed line, the ripple would travel along the feed line, bounce off the end, come back, bounce off the radio, and so on. In the same way, reflections and transmissions can add to each other, and they can also subtract from each other. This difference between the addition of signals and the subtraction of signals is what we call the SWR. There are two ways to get to the SWR. If you connect a 50 ohm feed line to a 100 ohm antenna, the SWR is 2 to 1. This is a theoretical SWR, and it tells you that there will be a ripple coming back from the antenna that is both adding and subtracting from the original transmission. Alternatively, we could use an SWR meter to measure the voltage differences between the high and the low part of a wave, and indicate on a dial what the SWR is. This is an actual SWR. The two are indicating the same thing, and we can use that to get from a measurement to an understanding of impedance matching between the feed line and the antenna. As a point of reference, if there are no ripples bouncing back, then there is no addition or subtraction, and the resulting SWR is 1 to 1. For completeness, I should point out that the rabbit hole is much deeper than this explanation, and I'll revisit this topic in the future. Now for the final piece of the puzzle. A piece of coax in amateur radio is 50 ohm. If you have an antenna that is 50 ohm, that's perfectly fine as an antenna system. Of course, antennas are not so accommodating. A dipole has a feed point impedance of about 75 ohm. A folded dipole has a feed point impedance of about 300 ohm. Each different antenna system has a different impedance and thus needs different transmission line connected to it. So if you look at a 50 ohm coax connected to a 300 ohm folded dipole, you know that the SWR is going to be 6 to 1. However, if you connected a 300 ohm ladder line to the same folded dipole, the SWR would be 1 to 1. What this means is that the coax would have waves rippling back and forth and the ladder line would not. The coax would have a particular loss and each ripple going back and forth would be subjected to that loss, where on the ladder line the loss would only apply once, on the outbound leg, since no energy would be bouncing back. As an aside, this loss is experienced as heat, and if you're not careful, it will melt your coax, or worse. That's not to say that SWR kills everything, but you need to be aware of what's actually going on. Now, I should point out one more thing. These bouncing waves, the ripples coming back, have information embedded on them. If you're transmitting voice or some digital mode, the ripples that bounced back would be broadcast with a slight delay, and the second bounce with another slight delay, and so on. This phenomenon could actually make your signal into gibberish. Coax has its place. It's a very flexible way of getting a signal from A to B. It's not affected by crazy nearby signals, and it's robust, not to mention cheap. If you actually need to get your signal somewhere, then it will pay to look at how best to use it, when to use ladderline, and how to organize your shack in such a way that the best signal makes it outside to the working end of your radio. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.